This is Chapter 3, Problem 26, where a soccer ball is kicked with an initial horizontal velocity, v0x, of 16 meters per second and an initial vertical velocity, v0y, of 12 meters per second. So the first thing we're going to do is to set up our table of everything we know. The questions that are asked are, what's the final velocity vector? That would be this vector over here. That's not really drawn to scale. The initial velocity vector is this one, v0. We don't know how big it is, but we just know its components. The final velocity vector would be the same size but pointing downward. We're also asked how long it takes to go the full distance in time and how high this is. So over here I've got my table. I'd like you to take a moment and see if you can fill out everything for t equals 0, t at the top, and fill out everything for the final when we're back at the ground. Please turn the recording off, fill this out, and then start it up again. Alright, so initially t equals 0, x equals 0, y equals 0. My acceleration in the horizontal direction is minus 0. In the y direction, it's minus 9.8 meters per second squared. My velocity in the x direction is 16 meters per second. That's given in the problem. And since there's no acceleration, that's the same throughout the entire problem. My y velocity starts out at 12 meters per second, positive. At the very top of the trajectory, it's 0 meters per second, and at the very end, just before it hits the ground again, then it's the same size as it started, but it's in the minus direction, so minus 12 meters per second. My final y position is 0. I'm back at the ground. I don't know the height of the trajectory, and so I have to find some of these things out. Now, I don't know what the time is when I hit the ground, and I don't know at the top either, but I do know that the top is the final divided by 2. Okay, so let's see what we can find. The first question says, what is the velocity vector VF, okay, at the very end of the trajectory? So this is a velocity vector that's the same length as v0, just pointed in the negative y direction the same amount as it's pointed in the positive. So we can just use Pythagoras here to find out the total length. Now notice that it's minus 12 meters per second in the y direction. However, when you square that, that becomes positive. When you solve this, you've got 20 meters per second for your total velocity vector over here. The second question asks, how long does this take? Remember that the vertical direction dictates how long this event is. And so what we want to use is probably the simplest equation, the first equation, v equals v0 plus at. We want to use that with these variables here. And so I'm going to set that equation up. Vy equals v0y plus at. If I solve for t, that equals Vy minus V0y over A. Vy is minus 12 meters per second. V0 is plus 12, but I'm minusing it. And I divide that all by 9.8 meters per second squared. When you work that all out, you get 2.45 seconds. So the entire trajectory up in the air, back to the ground, is 2.45 seconds long. So over here, I can erase this, put in 2.45 seconds. I can also erase this. At the top, I know that it's half of that, which is 1.275 seconds. Okay. Now the third question asks, how high does it go? So I want to know h. And I can use one of two equations. I can use the v squared equation with number 3, or I can use the position equation, the first one. So let's try using the position equation and see what we got. So that says the height equals y0 plus v0y times t plus 1/2 ay times t squared. v0y is 0 plus 12 meters per second times 1.275 seconds minus 4.9 times meters per second squared times 1.275 seconds squared. When you calculate this out, this should all equal 6.23 meters high. I could also use the velocity squared equation, v y squared equals v0 y squared plus 2a y. So y is what I'm looking for, which is the height. That equals vy squared minus v0 y squared over 2a. Now, this is for the half interval up to the top. So Vy is 0 meters per second, and then minus 12 meters per second initially squared over 2 times minus 9.8 meters per second squared. When you calculate that out, you do get, sorry, I got the wrong answer up above. My apologies. This should equal 7.35 meters. So I'll have to erase this here. Sorry about the confusion there. Either way, you should get the same height. Sorry about that. Thank you.